Hello, everybody. Welcome to 5th International Symposium on Multidisciplinary Studies and Innovative Technologies. Due to COVID-19, we are organizing the symposium virtually. I hope this epidemic will end as soon as possible. Let's start the session. First paper belongs to Ahmet Shamil. Mr. Ahmet Shamil, are you ready or is online? Okay. Dear Ahmet Muhi is online. Huda Hamid is online. Okay. Mustafa Mahat Hamdi is online. Muhammed Hussein is online. Okay. I guess Afolabi Ojelade is online. Dear Afolabi Ojelade,
yes, I'm online.
Are you ready to present your study?
Yes, I'm ready.
Okay, you can start if you want.
Okay. Thank you. Okay. Good afternoon, the host. Good afternoon, fellow members of the conference. I hope you can hear me clearly.
Yes.
Okay. My name is Afolabi Ojelade. I'll be discussing on a topic titled Efficient Energy and QoS-based routing algorithm for wireless body area network. Now, this is the outline for the presentation. First and foremost, I'll be talking about the introduction, and secondly, rationale of the study. Thirdly, model of the proposed work. Fourth, binary forms of the data type field. And then fifth, I'll be talking about the efficient energy and QoS algorithm. Then the sixth point is the data security. Seventh point is simulation and performance evaluation, and I'll conclude with the conclusion. Now, for the introduction, wireless body area network is emerging as one of the most advanced communication networks nowadays. And first, also let me define what the wireless body area network is. A wireless body area network is a tracking system that connects the various parts of the human body through biosensors. The health monitoring technology can be used for continuous monitoring of human body for health-related purposes, which in turn can aid in early detection and prevention of diseases. The wireless body area network serves a variety of other applications such as personal entertainment, advanced sport training, life events, aviation, natural disasters, consumer electronic devices, and many more. The sensors in a wireless body area network measures the physiological parameters in human body, such as sugar level, temperature, heartbeats, and etc. Then forwards the physiological parameters, which is the physiological data of the human body, to the concerned medical authorities via the internet or intranet infrastructure. The sensors in the wireless body area network can be classified as implant nodes, body surface nodes, and external nodes, depending on the position of the sensor nodes with respect to the human body. The rationale of the study goes thus. We live in an era in which the rise of information technology has spread all across areas of society. This evolution has gradually affected the health field throughout the 21st century. Although advances have mainly been focused on supervised systems where the intervention of healthcare specialists was necessary. However, the global pandemic in 2020 and 2021 left a large of the population without regular face-to-face healthcare. This was a very important push against the clock for digital transformation of medicine and represents an unprecedented situation in history that can be used by government and health centers to further research and advance in the field of electronic health. It can be acknowledged from literature that long-term sustainability of sensor devices is considered a major problem for the effective operation of wireless body area network technology. The continuous monitoring of health information using sensors are deployed or implanted in the human body, which leads to decrease in energy of the sensors. In addition, data security is another challenge during which transmission of information from one point to another should be focused on. To deal with this issue, the study proposes an efficient energy and quality of service routing technique for relay node selection to improve energy efficiency of the network and secure data transmission. The proposed model is illustrated in figure 1 below. In the next slide, sorry. This shows the model of the proposed work. This is a patient in which 7 sensor nodes are implanted into the body system of the patient. Now, each sensor gathers different physiological data from the patient's body and then transmits it through the sync node. Now, before the data have been transmitted, an algorithm is being performed at the sync node, which helps in encrypting the data. Then the data is being transmitted through the server, through the network. Then an authorized medical personnel accesses this information using a private key in order to access the data. So this structure simply defines the structure of the entire model. The proposed method or model is categorized into 2 phases. Number 1, which is the network phase. The proposed efficient energy and quality of service-based algorithm consists of 7 heterogeneous sensors and a sync node. The sensor nodes are deployed in or on the different regions of the human body, while the sync node is placed at the center. The sync node simply collects the data from the sensor nodes and forwards it to the server for further processing. Temperature, blood pressure, electrocardiogram, electroencephalogram sensors, and other sensors are used to obtain patient's health information. The second phase, which is the data security phase. During transmission from the sync node, the data is encrypted using a public key, while at the receiving end, the data is decrypted by an authorized medical personnel using a corresponding private key. An asymmetric cryptography called RSA algorithm was applied in this work. Brief definition of the major components in the network phase. We have the body sensor nodes. These are microscopic devices that may be implanted or attached to the human body with the ability to fetch, analyze, and communicate signals to the sync node. Sync node. This is the node that receives all information from the body sensors and transmits it to the central database for processing. A server. A server is a piece of computer equipped with specific programs and hardware that provides services to other computers known as clients. In this context, the server is a central repository that stores, manages, and provides information upon request to the clients. In this design or in this model, a MAC protocol was applied or implemented such that it helps to filter critical packets from normal packets in order to achieve energy efficiency and enhance quality of service. The diagram for the MAC protocol is shown on the screen. Binary forms of the data type field. The data types are expressed in binary forms as displayed. The normal data is displayed or categorized or identified as 0, which is the binary form, while the critical data type is identified as 1 in binary form. Efficient energy and quality of service algorithm. The algorithm is aimed to enhance the network lifetime and QoS by routing the normal data. The normal data is initially identified as 0 over the best feasible path, utilizing a single up or multi-up transmission, while the critical data is transmitted directly to the sync node due to the level of its criticality. This is the algorithm for the EEQ transmission. Okay, at the initial stage, the nodes have been identified. Then the initialization of the sync position is noted. And then the sync broadcasts its position to all nodes and stores it. It checks if all body sensors are placed properly. Node N broadcasts the ID, which is the numbers of nodes in the body system on the human body. And broadcasts the position, each position of the nodes, likewise the residual energy and the quality of service messages. It then calculates the distance for each node. It calculates the path loss based on the distance d and senses the data. Now, when trying to sense the data, it sends if the data type is 1. 1 simply means critical. Now, if the data type is critical, it does transmit directly to the sync. Else, if the data type is 0, it transmits using the EEQ algorithm. It checks for the following parameters. It identifies all neighbor nodes, calculates the maximum residual energy of all nodes. It checks for link stability. Now, there's a condition here. It says if P is true, then it selects the best routing path. After that, it selects the next relay node, that's the forwarder node. Then after that, it sends data to the sync node. As the forwarder node sends the data directly to the sync node and sends data from sync node to the server via intranet or internet, then ends the algorithm, then ends the processes. The next phase, which is the data security. As we all know, that security is very essential when dealing with sensitive data, such as patient health information. According to our proposed work, an asymmetric cryptography algorithm called RSA was implemented. The purpose of this technique is to encrypt and decrypt the patient's physiological data, both at the sending and the receiving end. Asymmetric cryptography involves 2 secret keys, which includes public and private key. The patient's health information is encrypted using a public key during transmission from the sync node to the server. Then the data is decrypted by an authorized medical personnel using a corresponding private key. As the algorithm for the RSA. The next slide shows the simulation and performance evaluation. The simulation tool used for this work is OMNet++, simply because it supports graphical user interface and routing protocol. The performance of the proposed EEQ routing algorithm is assessed based on the network lifetime, stability, and throughput. The table below shows the simulation parameters. The algorithm, or perhaps the design, is rated based on the network lifetime and stability period. Now, we'll talk about network lifetime. Network lifetime is the availability of the network until the entire node in the network is depleted, while the stability period is the duration in which the first node in the network dies. The proposed network lifetime is compared with other similar works as shown below. Compared with other similar works such as no algorithm, RE attempts, IM simple, and so on. Another factor which this particular work was being compared was throughput. And throughput is the total number of packets received successfully at the sink or central node. Our proposed work achieved high throughput in contrast to the existing reattempt IM simple and no algorithm, as shown below. Here is the graph showing the performance of our algorithm compared to other algorithms. In conclusion, the EEQ algorithm helps to eliminate duplicate packets, reduce energy consumption, and enhance the working lifetime of the network. On the other hand, a patient's physiological data is encoded through the application of RSA algorithm. In an attempt to assess the efficacy of the proposed algorithm, it was compared with similar works such as reattempt, IM simple, and so on, and no algorithm on the basis of network lifetime and throughput. Patients with severe medical conditions are persistently monitored, and instantaneous information from the natural environment enables the physician to get a comprehensive idea of the patient's health status. Question?
Thank you for your presentation. Dear participant, do you have any question about the paper? Okay, no question. I wish you success. Thank you again, Mr. Afolabi Ojelade.
Thank you very much, Mr. Yes, sir.
Thank you.
I appreciate it. Thank you very much. And have a great day too.
Okay, thank you again.
All right.
Ahmed Shamil is online. Ahmed Muhi is online. Huda Hamid is online. Dear Huda Hamid. Mustafa Maat Hamdi.
Yes, Mr. I'm Zainab Najib Abdul Hamid with Huda Hamid.
Okay. If you are ready, you can start your presentation. You have two papers. Is it okay? No.
Now I will,
Okay,
discuss the presentation of effluence, but I have a problem with my laptop. Can I present with my phone?
Okay.
Just a minute, please.
Muhammad Hussein is online. Slimane Zohra is online.
Hi, Professor.
Okay. We are waiting.
Hi, Professor.
Hi.
I'm Morod Qasim Muhammad presenting instead of Huda, the second paper of her.
Okay, okay. Okay.
So I can share now.
If you are ready, you can start your presentation.
Yeah, I'm ready.
Okay.
Let's share it.
You present Huda's presentation, okay?
Yeah, design and
Okay.
simulation of H
Second
shape.
presentation.
Yeah.
Okay. Okay, you can start.
Yeah. Okay. Thank you. Design and simulation of H-shape and duplicate U-shape slots microstrip patch antenna for WiMAX applications.
Sorry, you have 10 minutes, okay?
Okay, thank you, Professor.
Yeah.
Our abstract on this paper, actually we design microstrip patch antenna and simulated using CST software to attempt to recover the requirement of the Wi-Fi WiMAX application. Actually, 3 scenarios described and designed to get the proposed one. The first scenario is design a microstrip patch antenna, rectangular, simple one. Then we get adding the slots to this layer to make to increase the inductive signal of the current path, also increasing the antenna bandwidth. Then we add the slot H in the middle of the layer. Then we add duplicate U slots in the top center and bottom center of H slots of the patch layer. This proposed microstrip patch antenna provides 2 different operation frequencies with different values of return loss. In the simulation result, we will explain more these performance. Basic introduction in modern wireless communication devices covers many frequency bands. Also requires more operational frequencies to support several wireless access services simultaneously, such as WiMAX or CDMA. For these frequencies. However, simple rectangular microstrip patch antenna has majorly background about narrow frequencies and also less single application, provides single application because it's operated at single frequency. In another side, it's the major required of the antenna is the wireless communication device supports several applications via a single antenna. The first scenario of our paper is design rectangular microstrip patch antenna. Simply, figure 1 describe this microstrip patch antenna, rectangular, basic one. And the table 1 represent the parameters of this antenna. These parameters calculated according to some equations also presented in the next slides. With using glassy FR4 with thicknesses 1.6 millimeter and also loss tangent 0.01 and the electrical constants 4.3. This calculation equation 1 represents the width of the patch antenna, and equation 2 represents the effective electrical constants, where equation 3 represents the length of the patch antenna, and equation 4 represents the effective length, where equation 5 represents the length extension, delta L, and also length on the width of the ground is presented in equation 6 and 7. Then next we adding the slots, H slots, and the rectangular layer in the middle of the rectangular layer with these dimensions to increase the antenna bandwidth and also increasing the inductive signals. More improving, adding another slots, single U slots in the upper and the top center of the H slots to increasing more the performance of this antenna. And then we adding another U slots to get the proposed microstrip patch antenna with adding 2 U slots, one in the top center and the other one in the bottom center of H slots to increasing more and increasing more than in the inductive signals and increasing the antenna's bandwidth. And also this antenna will provide two operation frequencies. Simulation results, according to the first scenarios is of H slots. This presents H slots microstrip patch antenna. Figure 5 presents return loss respective frequency. We can see the operational frequency for this antenna is approximately 3.5 gigahertz, with the return loss is minus 14.5 dB, and can see the direction is with 4.738 dB. By adding the U slots, single U slots to microstrip patch antenna, we can see the frequency. The operational frequency is almost the same. The previous one is 3.518, and the operational frequency and the return loss is become more or less. There is a little bit improvements, and also we can see the direction is become 4.789 is also a little bit improvement. When adding more U slots to get the proposed microstrip patch antenna, we can see this performance. We have two operation frequencies with different values of return loss. One is operation frequencies is 3.5 gigahertz with return loss is minus 18.74, and the other operation frequency is 4.5 gigahertz with return loss minus 15.5 dB. So we can see there is more improvement with the return loss values and also getting two operations frequencies. And also we can see the direction of this microstrip patch antenna becomes more better than before. Also, we can see these compares in the table 2. We can see the proposed microstrip patch antenna. It's perform better than the others types due to operation frequencies and also the values of these parameters from operation frequencies, return loss, directivity, gain, VSWR. In the conclusion, we designed microstrip patch antenna for WiMAX application because these frequencies provided the application of WiMAX communication system using CST software 2020. Also, the proposed microstrip patch antenna is improved by adding two different slot shapes. One is H in the center and adding duplicate U slots, one in the top center and the other at the bottom center of the H slots. Also, we can get the proposed microstrip patch antenna provide two operated frequencies and with the different values of the return loss. Maximum return loss is in the proposed antenna is minus 15.5 dB at operated frequency approximately 4.5 gigahertz. Based on these results, the proposed antenna structure is a good acceptance and enhances the rectangular microstrip patch antenna viable in various future of the WiMAX mobile applications. Thank you for your time and thank you for listening. If you have any question, I will be happy to answer.
Sorry, I missed my volume level. Thank you for your presentation.
Okay, Prof.
Dear participant, do you have any question about this article? Okay, no question. Thank you again. I wish you success in your career.
Thank you. Thank you.
Dear Huda, Hamd's first paper is presented by Zeynep Necip Abdülhamid. Are you ready to present? Dear Zeynep
Yes, sir.
Abdülhamid.
Can you hear me?
Yes, you can start your presentation.
Yes.
You have 10 minutes, please.
Just
The communication is corrupted, I guess. Dear Zeynep Abdülhamid, can you hear me? Okay. Dear Baumgart, are you ready to present? Matteo Baumgart?
Yes, moment.
Okay, you can present.
Thank you for the opportunity.
Okay. Not at all.
Hello, everyone. We are an interdisciplinary team of researchers in computer science and research management from Mittweida, Germany.
Dear Zeynep Abdülhamid, please wait a while. Mr. Baumgart is presenting. Okay.
You see the slide?
Continue, please. Continue, please.
Yes. Okay. Mittweida is a small town in Germany in the state of Saxony with a University of Applied Sciences with 7,000 students and more than 200 ongoing third-party funded research projects. Our team works in different departments, in the research department and in our newly Institute for Computer Science in Media and Research and Transfer. And thank you very much for inviting us to the IEEE International Symposium on Multidisciplinary Studies. And we are blessed to present our contribution, a framework for a co-creation driven research and transfer portal. My presentation is structured as followed. At first, I like to speak about the methods and state of the art. That means related research, portals, the role of transfer and ID portals, and research information systems. Then we look at the requirements for a co-creation driven research and transfer portal. I speak about the use case and system requirements, and in the fourth point presents the framework for co-creation driven transfer portal. And then I go to the results. The international trend towards digitalization has a long since affected research in transfer processes at university, colleagues, and regional innovation systems. These are supported in an organic specific manner by a wide variety of IT systems, such as research information systems, transfer portals, idea portals, or other database systems. And at the same time, international scientific approaches from the field of organization and marketing have been further developed of the field of innovation management in forms such co-creation labs or co-creating clusters. However, the IT systems mentioned above, these instruments are independent and often project-related solutions. The aim of this contribution is to analyze the current developments in information technology and to aggregate them conceptually to a co-creation-driven network, taking into account the latest findings in innovation research. At first, an analysis of existing systems must be carried out based on the state of innovation research, which is central to the success of IT-supported transfer instruments. In view of current developments in the portal landscape at universities, the focus here is on transfer and idea portals, as well as research information systems. In innovation research and service marketing, the creation of value is a central and frequently discussed concern, whereby today, due to fast market cycles and short product lifetimes, approaches to collaborative value creation. Co-creation, you can find application today as a potential business tool due to diversity and multi-focus contribute to solving these creating open processes barriers. In addition, the co-creation approach, value networks are a second important premise of the service dominant logic, as it provides a framework for co-creation of value with the object of realizing joint competitive advantages. A current approach, which also taken into account in the context of the above mentioned transfer project Saxony 5, this is a so-called dynamic network which aim at the factor of time and should do justice to ever faster interaction between partners. Transfer portals have developed repeatedly in the last 20 years, but also the requirement for university to be available at transfer partners. They are digital instruments designed to bring together providers and consumers in the early phases of knowledge and technology transfer. They are the technological successor to transfer fact sheets like these initial content basic informations of the competencies of scientists, reference to equipment and infrastructure, as well as concrete service offers. Therefore, aspects such as usability, data availability, up-to-dateness play a central role on the software side. However, almost all available portals are characterized by a low number of users because the added value for scientists of the university, but especially for companies from the economy, is not directly compared. It is necessary to test approaches from innovation research as to how these portals can lead to added value. The transfer portal of the project Saxony 5 is currently based on the application of the promoter model. At the same time, the design as an open platform and the integration of the co-creation labs running in the project create two added values compared to classic transfer portals. Research information systems are IT-based and marketing tools for universities that collect, process, and present data-based information about scientists and their research-related activities. They are e.g. externally funded projects or publications, collaborations, and so on. And the main focus of research information systems is not the interaction with the economy, but the provision of information about resources of the university. At the same time, these portals are used organization related for strategic decisions, controlling and reporting. Currently, the systems are being developed further and the trend of migration from individual solutions to open source based systems like Vivo is discernible. You can see our research information systems on the slide. Now I'd like to present the requirements for the co-creation driven research transfer portal. The use case is the project. The use case for the project is a network of the 5 universities of applied sciences in Saxony in Germany, in the cities Dresden, Leipzig, Mittweida, Zwickau, and Zittau. These are the locations, and the institutions represent more than 1,000 employees, 24,000 students, and about 800 third-party funded projects annually. The 5 universities have developed and agreed a joint transfer strategy to bundle and strengthen their activities for the transfer of ideas, knowledge, and technology within the network. And the objectives include cooperations with industry and society, joint communication, and improved external presentation. The implementation of the objects is carried out from January 2018 to the end of the year 2021 within the framework of project funding by the Federal Ministry of Education and Research in Germany. Of a total of 14 sub-projects of the joint project of the 5 universities, 8 are designed as so-called co-creation labs. And these co-creation labs have functioned in virtual space, especially since the beginning of the COVID-19 pandemic. For example, virtual transfer events, virtual meetings are the most common formats for the exchange of knowledge. Currently, access to the co-creation labs is possible via the Saxony 5 website. You see it in the paper. Also, this is a static website. Also accessible with the Saxony 5 website is the marketplace and the transfer portal. The transfer portal offers a search platform for transfer partners, and the marketplace is used to submit short description of requests in the field of knowledge and technology transfer. Both portals are currently characterized by an inadequate degree of usage, which is typical for such static portals. Therefore, a system is needed that meets the requirements of the users and sensibly networks existing objects, components, and systems. You see it in Figure 1, thus creating added value for the use. This requires a network that meets the following 8 requirements. The framework must take into the account of institutional framework conditions as objectified boundary condition. This includes the strategies like open access guidelines. At the same time, organizational and financial constraints are relevant factors to affect the function and scalability of the system. The second, the overall system is set up for 1 or more organizations, each which had a number of members with a partner network. The requirement therefore aims the integration of existing partners as well as the partner networks. At the same time, already existing corporations are to be implemented visibility. In addition to the implementation of interfaces to these objects, the portal must technically offer the possibility of co-creative collaboration. Publications, doctoral procedures, and patents provide an important basis for the knowledge and the technology transfer of universities. As they serve a relevant object in the framework, and they are often the basis for projects and corporations. Today, research results are mostly published online in the form of articles in scientific journals or conference proceedings. For the scientific conferences, workshops, and working meetings represent relevant activities in knowledge and technology transfer. The framework should therefore have a component for organizing these formats. Each university has a website and a research information system actually, and with relevant data on researchers and their activities. The framework should therefore provide a way to access the data of all systems and all websites and provide the user with relevant information. In this way, actors from industry and society will have an efficient access to the information and context for solving their problems. 6. Existing idea and transfer portals developed in the project Saxony 5 should be aggregated in the framework to an intelligent, integrated, and uniform solution in order to increase user acceptance and the degree of networking between the actors from science and industry. Then each institution has other specific transfer tools whose effectiveness embedding or connection to the framework needs to be examined. These could be, for example, a large-scale equipment database or a standard software such as the university's ERP system with interfaces to the budget or the human resources. The framework should continue to provide an interface to freely available solutions. By providing AI solutions, users from science and society should be able to identify the possibility of machine learning problem solving using their own data in order to competitive the data-driven challenges. One focus will be the provision of AI-based use cases developed at the university, e.g. game concepts, characters, objects, AI agents, or web applications, as well as the verification and dissemination. Furthermore, AI-based open source solutions are made available or bundled. Based on the 8 requirements as well as the quality related, the authors propose the first framework for a co-creation driven transfer portal. The framework forms a runtime environment and is interconnected with different components like an aggregator, and web server and database server, web clients, as well interactive components and assistance function. The interfaces of the research data related systems within the organization can be oriented in an optimal way. Furthermore, the basis for a holistic and scalable system is created. Now I like to describe the 7 main functions of the frameworks. First, with the aggregator, the framework has a central component that forms the interface to all other internal and external components. The internal interfaces are the web server, the database, and the web clients, as well as the local research information systems, interactive components, and assistance function. The external interfaces are external research information systems, external metadata on research-related objects, and external content. Requirement and informations. In addition, the aggregator contains important metadata required for the components to work together. This includes the rules and the processes of the individual components as well as the requirements. At second, the aggregator fulfills the function of a crawler and stores data in the components of the database, which fulfills the function of the data warehouse. The database contains information, meta-information of the downstream systems and files. The data storage must be open for the further processing and at the same time meet the requirement of data protection. The web server as a component is more than a classic web server. It also contains an SQL server for managing the database and also an email server. Therefore, there is not only interconnected with this, but also with the aggregator. The web client accesses the web server via HTTP. Via this, user can access the system via a web page. Furthermore, the web client is the interface to the assistance systems. The framework is designed as an open system that combines various assistance functions. Typical examples are the forum and chat function or the calendar function, e.g. for the transfer events. Furthermore, an assistance function should enable the establishment of contacts via email or social media. The aggregator provides the information for this by crawling contact information on the website and research information systems from the connected institutions and systems. The system is to be scalable with the possibility of integrating further interactive components, such as image and video data and communication systems. For example, the systems should have an interactive research funding component. This will be relevant funding database and establish contact between scientists and research funding institutions, such as foundations. In this way, classic activities such as a newsletter service can be replaced by other effective systems. With access to the international research information systems, through the aggregator, information about scientists and their research-related activities can be collected, proceed, and presented. Such is a complementation of the implementation. The framework has a sufficient metadata set which adequately arouses the interest of target groups addressed from business, science, and society. With the proposed system, we have designed a system for colleagues and universities that interconnect the co-creative collaboration of users from science, business, and society by interconnecting relevant and individual components. Furthermore, the 8 central requirements were identified and supplemented by qualitative requirements. And based on this, a system architecture was designed. By integrating the developed architecture in the 5 German university of applied sciences in Saxony, Germany, to establish the joint transfer strategy, it was possible to show the concept developed can be used in a target-oriented manner. It was possible to prototype the TP aggregator as a central component and to collect initial data, including associated metadata in the database. The web client can be used to query the data via HTTP, and this opens further areas in development as it had been determined that the UIs used in this process can be optimized in terms of usability and user experience. The same applies in the framework, which is an assistant system in the form of forum, chat, or calendar function. We are able to provide target support in various application scenarios. In the research environment of Mittweida University of Applied Sciences, the resulting concept was found extremely helpful as it promoted the collaboration of multiple research groups. At the same time, it formed the basis for an extensive IT project that will be implemented at the 5 university over the next 5 years. This concludes my presentation. If you are interested in the systems or in exchange, you can contact me also via these contact details. And finally, I would thank the German Federal Ministry for Education and Research and the conference organizers of the IEEE International Symposium on Multidisciplinary Studies and Innovative Technologies.
Thank you for your presentation.
Thank you.
If participants do have any question about the paper? Okay, no question, I guess. Thank you again. I wish you success in your career, Mr. Baumgart.
Thank you. Thank you.
Okay. Dear Zeynep Abdulhamid, are you ready to present?
Yes, sir.
Okay,
I'll
you can
present
start
this
your presentation.
I leave the laptop. I have a problem with it, so I will present from the phone.
Okay. Dear Zeynep Abdulhamid.
There's many problems today with my presentation.
You can share your presentation with share screen button.
I know, sir, but the file is cannot open. The mobile not supported the PowerPoint.
Okay.
Just
you can convert your file to PDF file format.
Just a minute, sir.
Okay.
Do you the presentation? My presentation will begin now.
Your screen not seen.
Do you see my presentation?
No. Yes, yeah, I see now. Okay, you can continue, please.
Okay, I will begin now.
Yes.
My paper will discuss the influence different dielectric materials for square patch antenna on radar cross section RCS.
Sorry.
The outline is the introduction.
Sorry. Yes, now right. Okay, continue, please.
Okay.
Okay.
Continue. Okay.
Okay.
About the introduction, square microstrip patch antenna, dielectric substrate, radar cross section, results and discussion, and finally the conclusion. In the beginning, I will talking about the general microstrip patch antenna, which is also known as a printed antennas, operates on microwave frequency of the 1 gigahertz. Microstrip antenna was invented by Bob Munson in 1972. A microstrip patch antenna consists of a radiating patch on one side of a dielectric substrate, which has a ground plane on other side. The patch is generally made of conducting material such as copper or gold and can take many possible shapes. This figure shows the basic structure of microstrip patch antenna. The blue one is the patch, which is here the square. This is the length and the width of this patch. The silver one is the ground plane, and in the middle, the dielectric substrate. The shapes of the patch conductors could be square, rectangular, dipole, circular, triangle, and circular ring, and finally elliptical. Dielectric substrate, there are various substrate material to design the microstrip patch antenna, and to select suitable material is representing significant factors in designing antenna. Moreover, it depends on the two main characteristics of substrate materials, which are loose tangent and dielectric constant. This table will show the name of the dielectric materials and the dielectric constant. For RT Roger, the dielectric constant is 2.2, for taconic RF 3.5, for backlight 4.8, for dopant 7.8. Here the basic structure of radar cross section RCS. In the left side, the monostatic antenna, which have the transmitter and the receiver in the same place or in the same location. And here is the patch antenna, the incident wave, and this is the backscattered wave. Here is the scattered radiation, and we will find the RCS, find if the object will detect. For the results and discussion, in the first figure, when we use material, from this figure, we will show here when the incident angle is 0, and when the figure B, when the incident angle. From that figure can be shown that the main loop magnitude will be bigger than in the 0 degree. And the RCS will be bigger than 60 degree. The figure 2 the RCS for SPA with deponent 951 SPA, which is the square patch antenna. Here's the RCS value for 0 degree is larger than 60 degree. Also, the side loop of 0 degree of the target is having more fluctuation compared to 60 degree. The results indicate that a slight change made on the target could give a different readings of RCS. Number 3, RCS of the SPA with RT Roger 5880. Here is the RCS value for RT Roger at 0 degree is larger compared with 60 degree, since large main loop magnitude, here is in the figure A, will show that the main loop magnitude makes the target outline more visible. Thus, RT Roger at 60 degree is more easily to detect. And the RCS for SPA with taconic, with dielectric material taconic, shows the main loop magnitude for taconic is 60, and 60 degree is smaller than taconic at 0 degree. These results indicate that the differentiation of two angles for taconic is 60 degree is also more visible compared to taconic at 0 degree. In this table, we'll show the comparison between the various substrate material at angle 0 and 60 degree at 30 gigahertz. Let's compare the substrate material, the first one backlight, the second deponent, the third RT Roger, and finally the taconic, the fourth one. Here is the RCS at 0 degree and RCS at 60 degree. And the operating frequency for SPA here is 2.4 gigahertz. From this table, the conclusion obtained from this reading is that the deponent is material with SPA have lower RCS, the lower RCS here in 60 degree. But for the RT Roger has a greater RCS with 60 degree. The studying at the conclusion, the studying of scattering and the electromagnetic energy for various substrate materials for SPA has a significant goal in understanding the phenomena of RCS of the target. The CST software was used in the project for measuring the RCS of different materials. Deponent 951 material SPA have lower RCS than other substrate materials for monostatic radar at 0 degree. RTA Roger material has. That's all about my presentation. Thank you for listening.
Thank you for your presentation. Dear participants, do you have any question about this article? Okay, no question. I wish you success in your career. Thank you again.
Thank you, Mr. I'm very sorry about my problem, my laptop.
No problem. Okay.
Thank you very much.
Dear Ahmet Shamil is online. Dear Ahmet Muhi is online. Dear Mustafa Maat Hamdi is online. Dear Muhammad Hussein is online. Dear Silimania Zohra is online. Okay. I wish I want to end the session, dear participants. Hope to see you at next session. Have a good days. Thank you for your attending.
Thank you, Professor.